So we have our factors determined. They are x minus 2 and x minus 4, both set to equaling 0. We're now going to apply the zero product property, which means both of them need to be set to 0 separately. So we have x minus 2 equals 0, x minus 4 equals 0, which of course turns into a x is positive 2 or x is positive 4. Now the next step is to determine whether or not either of these are an extraneous solution. The only way to determine that is to look at whether or not these values plugged in as a denominator will become a 0. If they become a 0, then it is an extraneous solution, which is spelt extraneous. X cannot be 0 as a denominator, ever. Let's look at another problem. 3x over x minus 3 equals 2x plus 3 over x minus 3. Again, the first thing we have to do is factor out the least common denominator, which is, of course, our x minus 3, which factors out on this side, and x minus 3, which factors out on that side, leaving us with 3x equals 2x plus 3. Now, we know from algebra how to get this to equal what the value of x will be. If we move this over here, subtract it, we have a value of x equals 3. However, if we go to put 3 in as x up here, 3 minus 3 is 0. Therefore, x equaling 3 is an extraneous solution. It's not going to work. So your division by 0 is undefined. So this equation has, in fact, no solution at all. So the correct answer to this would be no solution. Moving on to example 2b. Let's look at a different type of setup. 2x minus 9 over x minus 7 plus, I'm having issues with my pen tonight, I'm sorry, x over 2 equals 5 over x minus 7. Now if we evaluate both of these sides of this equation, you can see our least common denominator is going to be 2 times x minus 7. So when we multiply 2 times x minus 7 on the left side, and then we multiply 2 times x minus 7 on the right side, actually the only thing we eliminate is x minus 7 as a denominator. It still has to be multiplied here. It still has to be multiplied, or this 2 value has to be multiplied here. So once we distribute that, we end up with 2 times 2x minus 9 plus x times x minus 7, because all we eliminated from this was the 2, equals 5 times 2. Now we need to distribute. We're going to have 4x minus 18 plus x squared minus 7x equals 10. We need to group like terms here. So we have negative 7x, we have 4x, which together will give us negative 3x. We still have x squared, we still have negative 18, and that still equals 10. I'm going to reorder these in standard form, which means descending from the highest degree. So my equation is going to be x squared minus 3x minus 28 equals 0. Now it comes to factoring. I need the factors of negative 28 that give me a sum of negative 3. If I start thinking about what factors would get me there, I know that 7 and 4 multiplied together give me 28, so let's start with those. What I need is a negative 28, so one of those is going to need to be negative, but I need it to be a negative 3. So that means the larger of the two values needs to be the negative number, so that my answer is negative 3. So I now have my terms, or my factors, in order to factor this out. So this polynomial is going to equal x minus 7, x plus 4 equals 0. Again, using the zero product property, I have x minus 7 is 0, x plus 4 is 0, which gives me the two answers of 7 and negative 4. Now, if I take these and go back to the original equation, which is a couple screens ago, and look here, if I plug in that value for 7, I'm going to get a 0 in the denominator, which tells me that is not a solution. So I can automatically eliminate that as an option. The only solution to this question is negative 4. I am skipping over to example 6, past the application problems. Now we're going to look at solving rational inequalities algebraically. We're going to look at these with this problem using the LCD, both as a positive and a negative number. So if we look at the LCD of x plus 5, we are going to look at it from a standpoint of it being greater than 0. We're also going to look at x plus 5 less than 0. And I'll show you where that is going to come into play in a little bit. Let's start with the problem. Multiplying by the LCD on both sides. So that's x plus 5 on the left, x plus 5 on the right. That's going to eliminate x plus 5 on the left, leaving me with x less than or equal to, distribute this 4x plus 20. I'm going to move the 20 over to the left side in order to start the isolation of my x. And I get x is greater than or less than, or greater than or equal to, a negative 12. Oh, I'm sorry. It doesn't equal negative 12. Negative 3. I still make mistakes. All right, so we have x is greater than or equal to negative 3. Now I'm going to look at the sign of the least common denominator. It is positive. I am taking x plus 5 being greater than 0, or this first one right here. If I have x plus 5 is greater than 0 and I solve for x, I have the answer that x is greater than negative 5. So my answer for this problem or this inequality needs to incorporate both of these things. On a number line, if I need an answer that is greater than negative 3 and greater than negative 5, I can simplify that by saying x needs to be greater than or equal to negative 3. That will also encompass the greater than negative 5 answer. Now let's flip to that other one where I said we were going to focus here. So let's look at the same problem again. We have 8 divided by x plus 5. Now it's going to be greater than or equal to 4. Recall the last time I wrote this, it was less than or equal to 4. That makes a difference. So this is going to be 8. We're going to factor out the LCD just like we did on the last problem, which is the least common denominator of x plus 5. Eliminates it on the left, leaving us with 8 greater than or equal to 4x plus 20. Factor this out, I get 4x and negative 12, and ultimately x is less than or equal to negative 3, which is very similar to the last answer, but the sign is flipped. Now, I'm going to look at my x plus 5. I know that x plus 5 this time needs to be less than 0. So x is going to be less than negative 5. So I have this, and I have from here, x has to be less than or equal to negative 3. So if I want to combine these two, I can simplify that to say x needs to be less than negative 5. That encompasses both negative 3 as well as negative 5. So that is my final answer. That is it for this section. Hopefully that helps you guys out a lot. And stay tuned for 5, 6 next. Thanks.